Welcome everybody. In this session, we will try to learn more about the periodic table. We will understand what is the modern periodic law, and we will also learn about the long form of the periodic table, that is the modern periodic table. Now, from your previous lecture, you would be knowing that Mendeleev's periodic table was an fantastic attempt in classification of the elements, but the number of demerits were more compared to the merits. A major problem actually with the periodic table arose because the knowledge about the structure of an atom was incomplete during that time. Finally, it was the English scientist Henry Moseley in the year 1913 who proved that atomic number is the more fundamental property of an element than its atomic mass. So children, remember this important point, that Henry Moseley proved that atomic number is a more fundamental property of an element than its atomic mass. And the statement of the modern periodic law was then given as follows. That is, the properties of the elements are the periodic functions of their atomic numbers. So what difference do you find between the earlier Mendeleev's law and the modern periodic law? Yes, the major change, that is atomic number. Mendeleev's periodic law talked about atomic masses, but the modern periodic law talks about atomic number. That is, the physical and the chemical properties of the elements are the periodic functions of their atomic numbers. So knowing that atomic number is the fundamental property of the element, the modern periodic table was constructed. Now let us try to understand what the structure of the modern periodic table is. The modern periodic table consists of 7 horizontal rows which are called periods, and because they are 7, obviously we will number them 1 to 7. Also, there are 18 vertical columns in this table, and they are numbered as 1 to 18. The 18 vertical columns are called groups. So we can summarize as the modern periodic table consists of 7 horizontal rows called periods numbered from 1 to 7 and 18 vertical columns which are called groups, that is numbered from 1 to 18. All the elements are arranged in their increasing order of atomic number. Atomic numbers are indicated in the upper part of the boxes in which they are fit. Now, if you look at the modern periodic table, you will find that apart from these rows and periods, you have 2 separate rows at the bottom. Those 2 separate rows at the bottom are the lanthanide series and the actinide series, very important elements. They are the lanthanide series and the actinide series. So total there are 118 boxes in the periodic table, including the 2 series. If there are 118 boxes, it means that we can place 118 elements. And now all the 118 elements are discovered. So let's summarize once again. The modern periodic table consists of 7 horizontal rows called periods. Periods are numbered 1 to 7. It consists of 18 vertical columns called groups numbered from 1 to 18. The atomic numbers are indicated in the upper part of the boxes. Apart from these 7 rows, there are 2 separate rows at the bottom of the periodic table. They are called as the lanthanide series and the actinide series. Total in total there are 118 boxes, it means that there are 118 elements. And all these elements are discovered. Apart from this, what is interesting is that the modern periodic table is divided into 4 blocks. Let us look at the structure, and which it's very clear. So what did I say in the beginning? That there are 7 horizontal rows, 1, 2, 3, 4, 5, 6, 7, and 18 vertical columns. As you can see, the numbering starts from here, 1, 2, 3, and so on till 18 vertical columns called groups. And if you look at the periodic table, at the bottom, as I mentioned before, there are 2 separate series, that is the lanthanide series, the first one La, starting from lanthanum and ending in lutetium, to the actinide series, that is actinium, to lawrencium. Other important point, that the whole modern periodic table is divided into 4 blocks. They are the S block, the P block, the D block, and the F block. So, as you can see, the S block elements are in group number 1 and 2. The P block starts from 13 till 18. The D block is in the middle, that is from 3rd to the 12th, and the F block is at the bottom. An interesting aspect of D block elements is that these elements are also called transition elements. Now we know the meaning of transition. Transition means change. So if you look at the modern periodic table, on the left you will find generally metals, and on the right you will find the non-metals. So in between you have a transition, that there is a change as we move from left to right. You will find that there is a change from the metallic to the non-metallic property. That is why the D block elements are also called transition elements. So this is a very important word which you should know, transition elements. And at the bottom we have inner transition elements that belong to the F block. So let's summarize once again. The modern periodic table consists of 7 horizontal rows called periods and 18 vertical columns called groups. There are 118 boxes, indicating that 118 elements are placed in the periodic table. The atomic numbers are written on the upper part in the box. All the elements are arranged in their increasing order of atomic numbers. Apart from the 7 horizontal rows, there are 2 separate rows at the bottom, which consists of the lanthanides and the actinides. The modern periodic table is divided into 4 blocks. Group number 1 and 2 constitute the S block. Group 13 to 18 constitute the P block. Group 3 to 12 constitute the D block. And the F block is at the bottom, consisting of the lanthanide and the actinide series. D block elements are also called as transition elements. They are called so because they are placed between the metals on the left and the non-metals on the right. And the F block elements are also called inner transition elements. I hope you got an idea about the structure of the modern periodic table. Another important point of the modern periodic table that everybody should know is this specific line, as you can see here, which is in the form of steps. This line is an imaginary line. We call this as the zigzag line. Now obviously it is zigzag because it looks zigzag. Now what is the speciality of this line is that if you look at the elements which are on either side of this line, you will find that they are metalloids. That is, they have the property of both the metals and the non-metals. So if you look into the periodic table, you know that the metals are placed on the left and the non-metals are placed on the right. And as you move from the left to the right, you can see that there is a transition of the properties, that is the metallic properties, and its zigzag line indicates that yes, there is a transition. And so around this zigzag line you will find the elements to have in between properties, that is they are neither metals nor non-metals, or we can say that they are both, that is they are the metalloids. So the modern periodic table was a resounding success, and that is what we follow today, primarily because one of its main features is that it is based on the atomic number. Now you know atomic number is related to the number of protons, or we can say the number of electrons, because the number of protons and number of electrons in an atom is the same. So when we talk about reactivity of any atom, you know atoms donate electrons and they accept electrons. So the reactivity of an atom depends on the number of electrons in its outermost shell, that is the valence shell. And so when we consider the reactivity, atomic number plays an important role. Since the modern periodic table was based on atomic number, most of the problems that were associated with the Mendeleev's periodic table got automatically solved. So you have to remember this critical point, that modern periodic table is based on the modern periodic law, which states that the properties of the elements are the periodic functions of their atomic numbers. Yes, the properties of the elements are the periodic functions of their atomic numbers. An atomic number is basically the fundamental characteristic of an element because it is related to the number of protons, or we can say the number of electrons, and the number of electrons decides the reactivity. Now coming to this table, if you remember, Mendeleev's periodic table was a failure because of its inability, yes, because of its inability to place isotopes. Now what are isotopes? You know, isotopes are atoms of the same element having the same atomic number but different atomic mass number. Placing them in the Mendeleev's periodic table was extremely difficult, but this problem was solved because in the modern periodic table, the elements are placed on the basis of their atomic number. So isotopes have the same atomic number. For example, isotope of oxygen or isotopes of chlorine, they have the same atomic number. So where will they be placed? Yes, they will be placed in the same position. So if you look at the table and you see here there is chlorine, right? So all the isotopes of chlorine will be placed in chlorine where it is right now. Oxygen will be in oxygen. So isotopes got the same position, right? The problem was solved. Now other problem, if you see in the Mendeleev's periodic table, was a problem of cobalt and nickel. Cobalt comes before nickel based on its properties, and in the Mendeleev's periodic table the atomic mass, as you know, of cobalt is greater than of nickel. Still it is placed before nickel in the Mendeleev's periodic table. Even in the modern periodic table, cobalt is placed before nickel, but we are not bothered about that. Why? Because we are not bothered about the atomic mass. We take into consideration the atomic number. What is the atomic number of cobalt? You can see here atomic number of cobalt is 27 and that of nickel is 28. So when you consider the atomic number, cobalt comes before nickel, that is 27 comes before 29, and so even this problem is solved. Then the periodic table of Mendeleev had a problem with zero group elements which were not there at that time, but the modern periodic table, the zero group elements are placed at the extreme right. As you can see here, they are at the extreme right, that is helium, neon, argon, krypton, xenon, radon. So The modern periodic table had solved some issues with the Mendeleev's periodic table. The issue of isotopes was solved. The problem of cobalt being before nickel was solved. The zero group elements was solved. But even today we have one small issue, and that is hydrogen. Yes, hydrogen is a non-metal, and you can find hydrogen even today along with metals. So position of hydrogen is ambiguous even today. So all these points are very important while writing the structure of the modern periodic table. Thank you.